So, hello to first Sir Greg and our flyer of record, Sir Julian, our other mentor, Dr. Tanzu. We are Team 6, Ateneo de Davao University Rocketry Team, and this is our flight readiness review. So, I am Franz, the team lead of this group team, and without further ado, let's start the review of our rocket. So I'll give the floor to our first presenter, which is the flight operations for the Cebu rocket. Right?
Not getting any audio if someone else is talking.
um, with our concept of operations for our rocket launch for 10 feet COTS category, the simulation is based on open rocket with 7 phases from launch, reaching its calculated simulation apogee of 10,206.69 feet at 5 miles per hour wind speed. And when it starts to descend, drogue chute will deploy, and when the rocket will reach at 820 feet, main chute will deploy and will enter the landing and recovery phase. From our open rocket simulations, the rocket will reach its apogee at 10,206.69 feet at 5 mph wind speed, 98.43 feet per second foray velocity, 961.29 feet per second for its maximum velocity, and 215 seconds of flight time.
Okay.
Right. Okay. For the structures of our rocket, I'll hand over the floor to our structures lead, Avery. So Avery.
Okay. So for these structures, we'll be having uh, a 200 centimeter rocket, and then we'll be having a caliber of around 3.08 without the motor. And when we have the M2 100 G motor, it will be commercial off the shelf. We will be having our uh, safety margin, I mean stability margin at around 1.46. So here's a brief run through um, of our setup and our sectioning. Next.
So first, we have our nose cone. Uh, our uh, our nose cone is acquired commercially off the shelf. So it is manufactured through filament winding process, and it's 78.5 centimeters in centimeters tall. So as of now, we don't have it, but it is to be shipped to us, and it has no nose cone tip yet. But our plan for the nose cone tip is to have it in aluminum T6, and we'll attach the nose cone tip to the nose cone after we acquire the nose cone and the nose cone tip. So our nose cone is actually commercially off the shelf. It is once again in filament winding process. So it is also it's made of fiberglass. Fiberglass.
Okay.
So for our nose cone extension, it is made out of first of all, it's 97.5 centimeters tall, and it is made out of 4 layers of 300 CSM, which is chop strand mat, and it is it can be seen directly on the slides here and the engineering drawing on the left. Next slide.
Okay, so for our coupler, which is our avionics section, we'll be having it around at the length of 36 centimeters with a switch band of 3 centimeters on its center. So can we show our camera? Okay. Uh, Please, this is Sanba.
Can you use can I'll redirect the focus on the other camera. Excuse me, Dylan. Remove the share screen. Wait for a while.
So this will be the nose cone extension. So this is its forward uh, opening, and this will be its aft opening. So we have already we have already uh, drilled a hole for it for these bolts. So this will be the coupler's forward part, and then here we are connecting it with a steel rod that is connected to a female eye bolt on one end and another female eye bolt on the other end. For this one, as you can see, there will be a designated two hole for uh, steel rods, which will be supposedly attached with these ones, these two rods, but we are not attaching it now. So here we have the steel rods, and inside this one is our avionics. So our M2 M3 sized bolts will be attached here on these holes, and our shear pins would be also attached to this to the aft part of this coupler. So should we
Okay,
move on?
so the bottom half separates, but the top half stays attached. Is that correct?
Wait, I'm sorry.
The bottom half is where your separation is, but the top half stays attached. Is that
Yeah, for the
okay?
coupler it will be attached since the breakoff point of the top part of our rocket will be on the forward half of our nose cone extension, which would be supposedly on this part.
Okay. And you'll be using shear pins up there as well, correct?
Should we move on?
Yep.
Okay. So proceeding. So proceeding, we also have our fin can, which is at about 106 centimeter in length, and we will be having a motor tube that is 65 centimeters long, and which this follows our motor tube. I mean our motor that will be purchased commercially off the shelf. So it will have a diameter of around 98 millimeter. So our fins are attached to our motor tube. So we will also be utilizing a through the wall technique for our fin attachment, and we will be using four fins. So as for the fin can, okay. So this will be the coupler, and then this will be where the coupler and the propulsion section will be attached using shear pins. So can you guys please? So this would be the four fins that were attached to our motor tube, and then we have also specifically placed uh, centering ring here and another here and another on this part. We are still yet uh, to finish our propulsion section with our thrust plates. So yeah, I think that would be it for our fin can for the propulsion section.
What are you using for motor retention?
Should we proceed?
Can you hear my question?
Again?
What are you using for motor retention?
For motor retention, we will be using instead of using motor retainers, we will be using two thrust plates that will be not knotted on this aft part of the propulsion section.
Okay. And then on the fin can, are there going to be epoxy fillets on the inside and outside there when completed? I think we lost audio on you there.
Can't hear you.
Hello, hello. Okay, sorry for that one. Um, so supposedly our fins are already attached to the inside of our inner tube. So it was already fillet. We have already placed fillets on this one, and then after we get to finalize our propulsion section, we will be putting fillets on the outside as well.
Okay, good.
Okay, thank you, sir. Should we proceed for the next slide?
Yes, go ahead.
So as you can see here, these are the fin flutter calculations. So for the fins, we actually use apogee rockets to calculate our fin flutter, and we inputted G10 for the materials of the fins, and as you can see here, uh, the required or the critical uh, velocity is in 700. We're almost 800, and our calculated is around 300. So that gives us a margin of safety of around 74 or 59 in feet per second.
Okay.
Should I proceed?
Yes, go ahead.
So for the minor components, I'll give it back to Avery.
Okay, for our minor rocket components, here we have our bulkheads and centering rings. These are 1 centimeter in width, so I mean in depth. So we also have these three on the picture. These are our bulkheads, and we have used positive mold for this one for these ones, and then we used a layup process of chop strand mat of 300 on these ones, and then up until we get to reach our desired depth. So with this one for the bulkhead, the same technique applied for the centering rings. Now for our eye bolt, we have here our M10 eye bolts. These are attached to a steel rod from end to end of our from the what do you call this? From the steel rod that is penetrated inside our avionics section. So uh, one eye bolt from each ends. Now for our rail buttons, we also have it on. We also had our rail buttons manufactured and fabricated by a local manufacturer. But in the US, we will be purchasing. We have already purchased online two rail buttons from Apogee rockets. We will be using 1515 rail buttons, by the way.
Okay. I have a question on your eye bolts. Are you doing, so is that where your recovery lines are going to be attached to?
Yeah, supposedly. It will
Are
be where
you are you doing, or is there any kind of lock nut or anything on those to prevent them from spinning and unthreading during recovery?
Yeah, we will be applying Loctites when we get to finalize our rocket.
Okay, great.
Can we now proceed to the next slide?
Yes.
Okay, thank you. Next slide. Okay, for since we're done with the air structure parts, then this is our propulsion part. Just a very quick presentation for this part. We'll be using commercially off-the-shelf Aerotech M2 100 G4. Uh, it has a the specs are here, but most importantly, it has a total impulse of 7,802 Newton seconds, average thrust of 2,100 newtons, peak thrust of 2,968.1 Newton seconds, and thrust duration of 3.7 seconds. Uh, can we? Is that? Do you
Do
have
you
any
guys
question?
do you guys have that motor already reserved?
Yes, we already bought the motor and it's already in the United States. So by the time we get there, we're uh, as soon as possible, we'll try to get it and check if the parts are there so that we can check the parts of the motor before the actual launch.
Great.
Is that good? Or should we continue to the next slide?
Looks like someone had a question there
Oh,
in the
Julian.
chat.
Comment if you lock tight and the AV bay needs to be accessed again for whatever. Wait for hours for the next set of lectures. Use cutter pin, it's instant. Okay, thank you, Sir Julian. We'll take note of that.
It's a good suggestion.
Take note. Or you just use U bolt. Okay, sir. U bolt. Yeah, we'll take note of that. The next slide. So for ejection wells, the ejection well, these are the dimension of the ejection well. It is 25.4 in diameter. This is in millimeters, and 38.1 in height. In height, we'll be using FFFG black powder for the actual launch. But since we can't access here in our country, we'll be manufacturing our own black powder using our own formula. And for the actual launch, we'll be using 6 grams of the FFFG black powder and 7 grams for redundancy charge, just in case the main charge does not eject. So we'll use the redundancy charge with more power just to ensure that it can pop out the parts that needed to be uh, ejected. Is that good? Thank you, sir. Next slide, please. So now that we're done with the propulsion and the aerostructures part, I'll hand over the avionics system to our avionics lead, Angela. Angela, I give the floor to you.
Okay. So for our avionics system, we have opted to use purely COTS flight computers. There will be two. So the main flight computer we're gonna use is the AIM Extra 4, and our backup redundancy flight computer would be the featherweight Blue Raven. And we're gonna open up the avionics bay to show you it being mounted on the inside.
Okay.
Just a minute. So open up the avionics bay. So for this, we opted to use a 3D printed avionics LED just for simplicity. And our M Extra is here, and on the other side would be the M Extra is here, and our Blue Raven would be located on the other side here. Uh, this is a voltage regulator just to prevent any voltage spikes on powering the units, and our batteries are Li-ion batteries located in this container here, which is can you show the slide the 3D model of the kasi might be better. Ano nakalagay sa slide? Ano nakalagay?
What material is the sled printed out of?
Again?
What material is the electronic sled printed from?
This is 3D printed PLA plus.
Okay.
Yeah.
Are you guys concerned about temperature with that? Because it does get pretty darn hot out there in New Mexico.
Oh, I think we'll be kind of okay since the temperature for this, like when it gets soft and melty, is around 200 degrees. So I think it'll be fine.
There's a concern there with it sitting on the pad for
Yeah, okay.
for a
This
significant amount of
makes sense.
time, and it can heat up in the sunshine, especially depending on the color of your rocket. So just want to call that out as a potential concern and something you guys should keep in mind.
So we'll take that into account and look for alternatives just in case. Okay. So I think that's oh. Oh, yeah.
Sir,
That's it for the
have you already, since we already run through our design, we'd also like to ask if you have any suggestions on the placements of the uh, avionics system on the sled or any changes on the design of the sled?
It looks okay as long as the orientation is correct per the manufacturer's instructions, and make sure you're doing some testing with your telemetry to make sure nothing's interfering with your transmission,
Yeah.
especially when you
yes.
got the steel rods in there.
Yes, for the orientation, we made sure that per the aim extra, the antenna should be pointing downwards to us. So that's how it's located right here.
Okay, great. Is that battery in the battery box there? Is there some kind of positive retainment to keep it from
Hi.
moving?
We haven't done it yet, but we plan to make some holes on the sides and zip lock it tight.
Okay.
I think that's it for the avionics section and stuff. So we'll go to the recovery.
Recovery?
One more quick
Next slide.
question.
Hi.
Do you have vent holes in the electronic bay?
Yes. On the switch band here, we have the hose for the pressure and altimeter of the avionics.
Okay, good. Just wanted to, that's
Uh,
one thing
One,
to double
two,
check.
three, 4 holes.
So we have 4 holes in the band.
Good, good.
Okay, so we'll move on to the recovery section.
Okay, recovery. For our recovery, we'll turn over our presentation to our recovery lead, Neil.
Yes, hello. So for our recovery system, we are going to have a main and a drogue parachute. The main parachute is situated near the nose cone end, and the main parachute, or no, the drogue is in the near the motor end, and the main parachute is near the nose cone end. And for both the parachutes that we are going to use, they're actually made here. For the drogue, it is a 48-inch hexagonal design parachute made of ripstop nylon with a 2 to 5 pound paracord. And then for the main, it is a 180-inch in diameter with similar materials, but with a spill hole diameter of 28 inches, which is about 2.5% of the area. And the estimated descent rates for both of these, for the drogue, it's around 16 feet per second, and for the main, it's around 65 feet per second, which is, I believe, under the recommended descent rates for both of the, for both stages of the rocket. Can we go to the next slide, please? So,
Yeah,
oh,
can you get,
I'm sorry.
can you repeat the speeds on the descent rates?
Oh, sorry. The main parachute is 16 feet per second, and the drogue is 65 feet per second.
Okay, 16. I heard 60 instead of 16, so that was a little.
My bad, my bad.
Okay, that makes more sense.
Yes. Okay, so moving on, for the shock cords that we are going to use, it is going to be made of a 5-inch tubular nylon, which is rated for 2,200 pounds or around 1,000 kilos. And for this paracord, it is 40 feet in length, wherein, it is going to be 10 inches, 10 feet on one side and 30 feet on the other to avoid the collision of the different parts of the rocket as it is slowly descending. And the second picture is our main and drogue parachute when it is rolled up, and it looks big, but it actually fits inside the rocket body. We have tried, and it fits snugly, but it does not friction does not interfere with the deployment of our parachutes. And then for the quick links that we are going to use, it is going to be an 8mm or M8 quick link, which is rated for similarly, which is around 1,000 kilograms or 2,200 pounds. And our parachute protector is just a fire blanket cut to shape, and it will be attached to the harness to avoid it being thrown away whenever the rocket is or the parachutes are deployed. So yeah, that's
Are
about it.
you
Any
okay?
questions about the recovery?
Yeah, are you doing anything to protect the tubular nylon where it lays against the edge of the tube to
Yes, we're
prevent?
actually. Oh, sorry.
No, you're fine. Go
Uh,
ahead.
okay. So we're actually going to provide further protection of the tubular nylon near the ends of where the black powder charges are through adding a baking soda solution so that it is going to be protected more. And yeah, yeah.
Well, that also, so the concern I have is where if once everything's deployed or your parachute's out, that shock cord where it lays across the edge of the tube, if the rocket's moving faster than expected during deployment, that can actually cut through the tubular nylon. And are you planning on doing anything to reinforce it or protect it in that area?
That is okay. I will take note of that and find further solutions for that.
Okay, just something to keep in mind because that's actually a very common failure mode. If your deployment is more rapid than expected, that's a very common place for your shock cord to get cut.
Okay. Any suggestions you have for this issue?
I've seen people do things like actually wrap fabric tape or even just duct tape around the area where it lays across that, when it's pulled out and it lays across the edge. You can also use a Kevlar sleeve that fits over the tubular nylon to add some protection as well.
All right. All right. Thank you. We'll take note of that. So I guess we'll give it back to our. So for our payload, I'll give it back to our avionics. So our payload will be.
So we've chosen to just use completely boilerplate payload made of stainless steel core in the shape of the volume of 1U CubeSat as per the guidelines of SAC.
Okay, so inert payload that stays with the rocket.
Yes. Yes.
Okay, gotcha.
So what's that?
Okay.
Okay, so that's it.
So I think that pretty much ends our slides on our end. So if you have any questions regarding our designs, then
Yeah, let me just go through the checklist here. There are so how many and what size of shear pins are you using?
shear pins. How many and what size? Shear pins? So we're using M2 shear pins. We actually have it in here.
Okay.
And we'll use 2 each shear pins. For each body tube.
For each separation point.
Yes, sir.
Okay. And yeah, and assuming you're planning on doing some tests with your deployment charges to make sure everything separates correctly with the shear pins.
Yes, sir. Yes, sir. Once again, we'll be using our formulated black powder since we can't access the FFFG, and we'll be following the formulas that we've also been using with our small scale rocket. So we've been doing this before, but with small scale, and we'll be doing it once again with this with our new rocket.
Okay. Are you planning on using commercial black powder when you're at the event, or
Yeah, yes, sir. We'll be using FFFG.
at the okay, gotcha. All right. And remind me, have you guys flown at the event before?
Not yet. This is actually our first time and the first time in our country.
Okay, okay. So a couple things to go over there to make sure you're aware of. Um, the teams are responsible for providing their own food and water during the event.
Yes, sir.
as well as transportation between your hotel and the launch site, which is it's about an hour drive. So you'll have to make sure that you have a rental vehicle and a driver. And sometimes the car rental rules in the US can be kind of a pain. So you might want to, or I would recommend getting that squared away ahead of time so you don't have any last minute issues there. Um,
So I have a question. We don't. We have for example, we have a driver's license here in the Philippines. Can we drive in the event for the recovery without the international driver's license?
that's a great question, and I don't know for sure. I'm well, and driving for so the recovery, you won't. I mean, the recovery will be on foot for the most part. There's a couple of roads out there, but you know, most often the rocket lands not right on, not on the road. So you can sometimes get closer to it, but then there will be some walking involved. But um, I'll have to find out about driving at the event. Honestly, I don't know how the driver's license situation. If the U.S. accepts a Philippine driver's license, I don't know. So that's something you need to find out for sure. And if it does, if it's accepted in the U.S., then at the event, it's not going to be a problem. Um, Let me see a couple other things here. Make sure you have proper ID with you. There is a border checkpoint between the hotel and the event where you can be stopped and they'll just want to see appropriate identification. So make sure you have that with you when you're traveling from your hotel to the event. Um, Chairs and tables when you're out at the event is your responsibility to provide. They will have tents, so awnings cover. So you'll have a assigned area where you'll have some covering from the sun, but you'll need to have your own tables and chairs. Um, Make sure that you're prepared for the weather out there. Last year, it was between 100 and 105 degrees Fahrenheit with there were 10 to 30 mile an hour winds out there, which was pretty nasty last year. So just make sure you're prepared for those kind of conditions. Sunscreen, lots of water, all that kind of stuff. Do you guys already have your traveler agents, your visas, and your hotel squared away?
Yes, sir. We have our bookings and we also have our business, the whole team.
Excellent,
We're all
excellent.
set. I'll also ask
Um,
more questions since these are the only chance that we can ask. Uh, Regarding also the dress code, I would just like to clarify how would we confirm that our dress code is enough, especially regarding the shoes or the boots. How can we say that it's
so
graded?
the requirements out there: long pants, no shorts. There's some pretty nasty plant life out there that is yeah, big spikes, sharp things, stuff like that. So shorts aren't allowed out on the launch site. You have to have long pants. Boots, as long as they are honestly any kind of boot is typically going to be okay. Tennis shoes, not so much, and definitely not any kind of sandals or open-toed shoes. Because again, there's some mesquite bushes out there that have big long spikes on them that I multiple times when I was here last year, I ended up stepping on some of those and pulling out big old spikes out of my boots. So you want to make sure you have good protection for that. Um, yeah, long it sometimes is not intuitive, but long sleeves are good to actually protect you from the sun, as well as a good hat and lighter colors. If you don't want to have, there were a few teams out there last year that the uniforms were, they had black shirts and black pants on, and you stand in the sun in line with all black clothing at 100 some odd degrees, and you get really hot really fast. So keep that in mind as well.
Yeah. So perhaps a final question. I'm sorry to be bothering you so much, but
Not at all.
regarding when we're gonna fly the rocket, when do we know that our exact date for our team to be flying the rocket, or is it after the registration that we find out?
So once you're registered it's pretty much a first come, first serve. So when you
Mhm.
arrive at the event, the first day or so, there are, well, the first 2 or 3 days you're in the convention center, and part of that is an in-person review of your rocket. So you'll have your entire rocket assembled and ready to fly without the motor and no deployment charges, no energetics of any sort. And you'll be in a queue, and you actually bring your rocket into a room, and you'll have a couple people that will go over it, very similar to this, but in person. And once you're, so you want to make sure you get that done, and then the actual flight days, you get out there, and you basically you get in line, and there's another pre-flight check, and then you get assigned your spot in the launch queue. So it basically depends on you being ready, having your rocket ready to go, having everything together, and being able to get out to the site.
Thank you. Oh, one last thing.
You ask
I
all the
was just
questions
like
you want.
to ask if, like, for example, for like the worst case scenario, we can have access to explosives, small scale explosives such as the black powder and the e-match for example, the logistic reasons. Are there available vendors in the event where we can buy the black powder chargers or the e-match?
Yes, Wildman is usually out there, and I would recommend
Like,
contacting him, and you can purchase and reserve stuff ahead of time, so he can have it. He can have your e-matches and your black powder at the site waiting for you. And I would recommend doing that ahead of time. But yeah, there's at least Wildman, and I think there's a second vendor there as well. But yeah, that those things will be available on site.
yeah, I think, thank you, sir. I think we're good.
Okay.
How about you, sir? Do you have any more questions? Or
Oh,
anything to
I'm
say?
good on this side.
Okay, sir. How about our mentors? Sir Julian and Dr. Tanzu. They are our is our flyer of record, and other one is our mentor.
I'm fine. I'll probably have more questions and that I'll throw in the chat.
It's good on my end too.
Okay, so I think we're done. Thank you for attending. We're very thankful for your time, and we're looking forward to seeing you in the event.
You bet. But make sure you get this submitted to Ezra right away, because the deadline for the
Yes,
video
sir.
review is just a few hours away. So
Yes, sir.
make sure you get that right away, so there's no problems there.
Sir, thank you.
Thanks. Have a good one.
Have a good one. Thank you, everyone.
Have a good one.